We are now on the roots function, so 6 and 7, your cube roots and your square roots respectively, but let's just do number 6 first. And then I think I'll just put the domain and range over here. Okay, domain. Very similar. I believe that we can plug in any x value that we want, even negatives, because with a cube root of a negative, we can actually get some value, and you know, it will come out. Where is my calculator? I'm gonna go grab my calculator first. So we can plug in any positive value, and you know, just in case, you can go ahead and try it out. If we have a cube root of a negative number, can we actually get a y value? I don't know, negative 98. Is it, yeah, you know, because negative times negative times negative will give us some sort of, will give us another negative value, and that is okay. So for the domain, we're going to have all real numbers on this one too. Okay, so negative infinity, comma infinity. The range, it looks like, you know, just looking at this graph, it looks like it might only in between certain values. But the thing with cube roots, it's a slow growth. It will go on forever, x ways. Well, how about the y's? It's just a slow growth. It will eventually hit y equals 8. And you know, we could actually figure out that value. Will it hit 8, 9, and 10? Let's try it out. If we let 8 equal to your y, 8 is equal to cube root of x plus 1. Let's go solve for x. So we're going to subtract 1 on both sides. 7 is equal to cube root of x. And then we're going to raise it to a power of 3. So 7 cubed, 7 times 7 times 7. X is going to be 343. So yes, eventually we're going to hit a y value that's going to be 8. It's just that it's going to take, you know, x equals 343. You know, so it's going to take us 343 for x in order to hit a y value of 8. So it will grow eventually, but it's just going to take a really, really long time. And also going backwards too as well. So for your range, it's also going to be all acceptable y values as well. It's just going to take a longer time than, you know, some other functions like your parabolas and your absolute values. Okay, so that's going to be that. And it's also going to be negative infinity, comma infinity, unbounded for number 6. Okay, well, this is your cube roots. Square roots are going to be just a little bit different because they only go one way. And let's jot down those. Domain, acceptable x values. Take a look. It starts at the -2 and then it goes to the right side. Okay, and so, and this is your least x value. Since this is your least x value, it's going to be x is greater than or equal to -2, and everything else is going to the right. That's your least value. Because this is our smallest least value, we're going to go -2, comma infinity, and we're going to bound that -2 because of that closed dot. Now let's go take a look at your range though. For your range, nothing is going downwards over here, but everything is going upwards. So since everything is going upwards, we want to do a y equals, y is greater than or equal to, and then there's nothing negative over here, but it looks like it's going to start at 0 because your starting point is -2 comma 0. So it's going to be 0 like this. Okay, so everything is above that 0, including 0, and we're going to have a similar, interval notation. Since our lowest value is 0, we're going to go 0 over here, but it's included, so we're going to have that bracket. Okay, let's go move on to the next portions, number 8 and 9. Aha, okay, so 8, it's our rational functions, the 1 over x, and then I believe it's graphed correctly, we have that negative, so it should be on like the second quadrant, quote unquote, and the fourth quadrant over here, and nothing on these. Okay, all right, so let's figure out domain and range, and I think it can be written a little bit differently. I'm just going to space it out. Okay, look at your domain. We have an asymptote at -1, at x equals -1. So x cannot be -1, but it looks like x can be other things, because if we have can x be -12? Yeah, because there's a y value over here. Can x be -0.2? 9999? Yeah, because there's a y value over here, and x can also be greater than that. X can also be less than that as well, but x just cannot be -1. So we know that x just cannot be -1. So how can we write this? Well, we can do two things. We can go like this. X is less than -1, or x is greater than -1. Okay? So x is less than -1, which is -2, -3, -4, -1.4, or x is greater than -1, which is -half, 1, 2, 3. It just, x cannot be -1. Okay, so this is how you're going to write this part. So it's going to be this portion over here. What I like about this is we can transfer this already into interval notation. What I mean by this is, so I'm going to write this and this, and then we have that or sign, the or word, and we're going to transform that into a symbol. So let's start with this one first, less than -1. That means that -1 is your highest point. And because we're not including -1, we're going to put that on the right side. And then everything else can be less than that. So we're going to have an unbounded negative infinity here. Okay. Let's take a look at x is greater than -1. This one over here, this is your lowest value because everything else is above it, greater than. So we're going to have -1 over here. And then everything else is greater than that. And then it will be infinities are unbounded. And we can have a union. So your or is going to be your union. Because all the x values can be that, it just cannot be -1. So very fancy. This is just a very, very fancy way of saying x cannot be -1. Okay, so that's super, super fancy for that. Okay, all right. So now take a look at your range. Your range is also very, very similar, where your y value cannot be -3. Okay, because you have that asymptote. So we're just going to write it in two ways. Y cannot be -3. It's very, very similar. So everything can be below that. Y is less than -3, or y is greater than -3. Okay, so this is going to be your inequality notation. Now to transform that into your interval notation, super, super similar. -infinity, comma, -3, but where it's not included, with a union of -3, comma, infinity. Okay, so you have your inequality notation, and then you also have your interval notation as well. Okay, let us do number 9. Oh, sorry, number 9. Okay, we have the e to the x, so we have an exponential function. I do want to remind you guys that over here, I think maybe I'll just draw it in yellow-orange, we do have an asymptote at the 1, even though it doesn't look like it. So I'm just going to graph that just to remind ourselves that we have that asymptote at y equals 1. Okay, let's take a look at domain and range. Okay, for your domain, it looks like everything is going to, I think we can plug in any x that we want, and then we can get a y value. I mean, it also looks from this value too, you know, we can plug in -6 and we have something. We can also plug in 8, and it will just be a huge number that's off this graph. Okay, so it's going to be all real numbers for the domain, so there's no restrictions for that. Okay, but there is a restriction for your range because there's nothing below this asymptote. Okay, I know it looks like it's touching y equals 1, but this graph does not touch it because of this asymptote. So, and since everything is above it, y is greater than 1. So be careful, we're not including the 1 because of the asymptote. Now to write this, because 1 is your lowest number, we're not going to use brackets for interval notation for number 9. Okay, so 1 comma infinity, both unbounded with the parentheses. Okay, I think I'm going to stop the video for right now, and then I think there'll just be one more final video.